Hi, as I mentioned in the previous lesson, in interactor PythonParts, we use createInteractor instead of createElement function. However, the function createElement can be used to create the preview. If you don't need preview, you can return the empty to avoid the error when you first load the PythonParts. Here you can click to any PythonPart and see the preview. It's empty for our Strip Footing PythonPart. Now we will see how to create a model for our PythonPart. In the process mouse message function, we check if user selects 2 points. Then we create a model and reset. We need one method to create a model. This method needs a building element, first and second input points as point 3D. Models contain foundation and walls. Similar with single foundation PythonPart, we create a list to hold the model. Then we add foundation model to this list. I will copy from single foundation. Building element input here. We don't use length parameter. Instead, we calculate the length by selecting points. Input the length as argument here. This method is the same with the single foundation. Now let's input variable for this method. Building element can be gotten from this building element list. First point is the first selected point, and second point is the second selected point. Let's run to check the tool. It works fine without error, but it didn't create any model. That's because in normal PythonPart, when you return the model in createElement, Allplan will automatically create the model. But in interactor PythonPart, you must create the model by yourself. To create a model, we use the function createElements in Allplan Python module. First argument is the document adapter that you can get from the coordinate input. Then you need the matrix 2D. Next argument is the model element list that we need to create. We may talk about the model UUID list in another tutorial. Now just input an empty list. None for the view reference object. Here you can see that we can create model after we select 2 points. But it's not in the right location and angle. It's always created at the 0 point. We need a method to transform the geometry. First argument is the geometry as polyhedron 3D. Then we need the reference point. This point is the location where you want to move the geometry to. It returns the polyhedron geometry. In this method, we will move the geometry to the reference point, then we rotate the geometry. First, we move the geometry. We need a vector from the 0 point to the reference point. Then we move the geometry using this vector. The 0 point is default. We can remove it. And maybe we only need one line. Now we can rotate the geometry. To do that, we need the angles based on first and second point. Then we use that angle as input for the derivation and the transform geometry method. To rotate, use the rotate function in Allplan geometry module. We need the geometry, the axis 3D, and the angle. We create the axis 3D using the reference point and the z vector. Now we can return the geometry and call the transform geometry method. Reference point is the first selected point. Here it is. We created the operation based on two selected points. We can create next operation as well. Now let's create the model for the wall above. We can copy from the operation and modify. Let's check the tool. We successfully create the wall above, but it's in the wrong location. It is using the first selected point as the reference point. But we need the reference point for the word above in the top middle point of the horizon. I can't find a way to get that point in Allplan geometry module. So I need to write a function that allows me to get the new point from the reference point. This new point is calculated based on the distance and the angle. We use math library to calculate the cosine of the angle. Because we need perpendicular with the angle, we add p divided 2 to the angle. Multiplied by the distance. Similar with the y, but we use sine instead of cosine. We return the moved point. Then we use this function to move the reference point from the first selected point to the middle of the horizon. Add the horizon height to move it to the top. Run again and it's good now. However, if you modify the size of horizon, it won't change. To fix that, we use the modify element property method. We can copy from other Python parts. First, it checks if we modify the property. Then, if yes, it will update the palette. It's updated now. That's all for this lesson. In the next video, we will see how to write a preview for this Python part. Thank you for watching and see you.